So let's solve this given differential equation. So we will begin by rewriting it as dy over dx equals to 1 divided by x plus y plus 1. Now we cannot separate the differentials here and make it a variable separable form. That's because on the right hand side we have 1 over x plus y plus 1, which is a function of x and y. So here what we will do, we'll make an assumption here. So we'll consider x plus y plus 1 equals to some variable v, and then differentiate both sides with respect to x. So that will give us 1 plus dy over dx plus 0 equals to dv over dx. Now isolating dy over dx, so we have dv over dx minus 1. Now we substitute this value into this original equation. Let's call it number 1. So equation number 1 now gives dv over dx minus 1. So that's equals to 1 divided by v. We have now dv over dx equals to 1 plus 1 over v, which is equals to v plus 1 divided by v. Separating the differentials, we have dx is equals to v divided by v plus 1 dv. Now we can see that this is now in the separable form. So whatever was given the original differential equation, now what we have done is we have reduced it to a variable separable form. So now we are ready to integrate both sides. Integration of dx, so that's simply x. Now to integrate v over v plus 1, what we'll do, we will add and subtract 1 to the numerator, so that we have integration of v plus 1 over v plus 1. So that will be simply 1 minus 1 over v plus 1 dv. So this should give us x is equals to integration of 1 dv, so that's v, minus integration of dv over v plus 1, so that's natural log of v plus 1, plus the constant of integration, let's call it a. Now we will substitute the value of v with this particular value. Let me box it here, x plus y plus 1. So we have x equals to, so we have v here, so v will be replaced with x plus y plus 1 minus natural log of x plus y plus 1. We already have a 1 here, so this will be plus 2, plus the constant of integration a. So here x and x gets cancelled out, and that leaves us with y plus 1 plus a, so that will be equals to natural log of x plus y plus 2. Now if we use the definition of logarithm, then we have e raised to the power of y plus 1 plus a, so that will be equals to absolute value of x plus y plus 2, which is equals to, so it will be x plus y plus 2 equals to e raised to the power of y times e raised to the power of 1 plus a. Now since this is a constant, this thing can be replaced with c. So we have c times e raised to the power of y, and that's equals to absolute value of x plus y plus 2. And this is the final solution to a given differential equation.